Hello everyone, welcome to my channel. I am Balaji Chandrasekharan. Now I will be discussing some more examples of using the Java streams. Factorial is applied to a non-negative integer and is a multiplication of all integers smaller than or equal to n. In this code snippet, we will learn how to write a factorial program for a given input number n using the Java streams. The code generates a stream of integers from 1 to n and converting each integer to a big integer object using the mapToObj intermediate operation. Then it reduces them by multiplying all the elements together using the reduce terminal operation by having 1 as the initial seed value, and the multiply method in the big integer class is used as an accumulator by passing it as a method reference. The terminal operation resulting in the factorial output as a big integer. A palindrome number is a number that is same after reversal of the same number. For example, 545, 151, 34543 are palindrome numbers, and strings like LOL, madam are all palindromes. Here is how we can implement a palindrome checking program using the Java streams. This code takes an input string str and check if it is a palindrome or not. It first cleans the input string by removing the spaces and converting all the characters to lowercase. Then it uses the instream.range method to iterate over the first half of the characters in the clean string. For each character at index I, it checks if it is equal to the character at the corresponding position from the end of the string. If all the characters match, the allMatch terminal operation returns true, indicating that the string is a palindrome. Otherwise, it returns false and that string is not a palindrome. An Armstrong number is a positive n-digit number that is equal to the sum of the nth powers of their digits. For example, 129 and 153 are Armstrong numbers. Now we will implement a code to check the Armstrong numbers using the Java streams. The value of method in the string class is used to convert the given input integer number to a string. The split method splits the string into an array of strings where each string represents a single digit. Arrays.stream method is used to create a stream for the string array. The mapToInt method is an intermediate operation which maps each string digit to its integer representation using the integer.parseInt method, resulting in a stream of integers. The map method is again an intermediate operation which maps each integer digit to its power raised to the length of the original string, effectively performing the power of operation. The sum method is a terminal operation which calculates the sum of all the power digits in the stream, which will be compared with the input number to verify whether the given number is an Armstrong number or not. Here is an example of doing the matrix multiplication using Java streams. In this example, we have two matrices, matrix 1 and matrix 2, which is represented as two-dimensional arrays. Here, we are using the range of the int stream class to create a new stream. The forEach method is a terminal operation and is applied to the three created streams to do looping within the matrix to do the multiplication between the two matrices, matrix 1 and matrix 2. Finally, the result holds the result of the matrix multiplication. We can use parallel streams to perform the multiplication operation in parallel for improved performance. Tree traversal using streams can be achieved by using a recursive approach. Here is a basic example of how we can traverse a tree using streams in Java. I have created a simple binary tree structure defining as a class tree node with the instance variables val, left and right. I shown here one way how to traverse the tree using the streams recursively as follows. In pre-order traversal, you visit the root node first, followed by the left subtree and then the right subtree. The method recursively traverses the tree by concatenating the stream of the current node's value with the streams generated from traversing the left and right subtrees. In the in-order traversal, you visit the left subtree first, followed by the root node and then the right subtree. This method recursively traverses the tree by concatenating the streams generated by traversing the left subtree, the stream containing the current node's value, and the streams generated from traversing the right subtree. In post-order traversal, you visit the left subtree first, followed by the right subtree, and then the root node. This method recursively traverses the tree by concatenating the streams generated from traversing from the left and right subnodes with the streams containing the current node's value. Each method checks if the current node is null to handle the base case of an empty subtree, returning an empty stream in such cases. Otherwise, it constructs the stream of node values by concatenating streams generated from the recursive traversal of the left and right subtrees with the stream containing the current node's value. Each traversal method returns a stream of integers representing the values of the nodes in the specified traversal ladder. You can then perform various stream operations on the stream, such as printing the values or collecting them into a list. The same approach can be applied to solve the problems like towers of Hanai using Java streams. Solving Sudoku using streams in Java is again not as straightforward due to the nature of the problem. Sudoku solving typically involves backtracking applications which are not well suited for functional programming paradigms like streams. However, we can still create a stream solution using streams to validate the Sudoku board for the correctness of the solved Sudoku. Here is a simple example of how we can use streams to validate the Sudoku board. The given code checks whether a given Sudoku board is valid by ensuring that each row, column, and 3x3 subgrid contains all digits from 1 to 9 without repetition. The isValid method uses streams to perform these checks efficiently. This code expects a input board object with a two-dimensional array, and it uses the inStream.range method to create an integer stream. It internally uses the intermediate operations like map, distinct, and flatMap, and the terminal operations like allMatch and count methods to validate a Sudoku. First line of the code snippet checks if each row contains all the numbers from 1 to 9 without repetition. It iterates over each row index from 0 to 8 and checks if the distinct count of numbers in that row equals 9. The second line code snippet checks if each column contains all the numbers from 1 to 9 without any repetition. It iterates over each column index from 0 to 8 and checks if the distinct count of numbers in that column equals 9. The third line in the code snippet checks if each 3x3 subgrid contains all the numbers from 1 to 9 without any repetition. It iterates over each subgrid index from 0 to 8 and maps it on the corresponding 3x3 subgrid. For each subgrid, it calculates the starting row and column indexes and checks if the distinct count of numbers in that subgrid equals 9. Finally, the response will be returned as true if all the rows, columns, and subgrids are valid. You can keep making progress towards your journey on learning and mastering using the Java streams by frequently applying and implementing more of those in your applications. Only real world examples can make you perfect. Share your knowledge and more code snippets by using Java streams with everyone, which helps everyone to interchange our knowledge. Thank you for watching my video.